VCET and Department of Computer Science Engineering, we once again welcome you, sir. Now, let us invite our resource person of this session, Dr. D. Surendran, sir, to move this session forward.
Thank you, ma'am.
Thank you,
Ma'am,
sir.
I'm audible?
Yes, sir, it's audible, sir.
Yes, ma'am. We'll continue.
Okay,
Good
sir.
afternoon, dear participants, and I deem it a great pleasure and thank the organizers for giving me an opportunity to share my views on the topic IoT uh, design and power blocks of IoT. Now the theme is IoT and blockchain. Now we'll start looking into the nuances or the buzzwords IoT and how it is powering in a higher level of abstraction. The screen is visible now.
Yes, sir, it's visible, sir.
Okay, thank you. Now let me start. So my session will be the outline is what is IoT, the architecture. Whenever you have any technology, we look into the architecture and the building blocks of IoT, and an introduction about the applications, this range or spectrum of applications, and the future of IoT. I may swing from the presentation to some sites and some other materials also, and it'll be like I like that this session to be interactive rather than be a monotonous talk, because this online mode of teaching nowadays has posted a lot of challenges because we don't see persons face to face. Right? So at any point, dear professors, I just like welcome everyone to interact with me at any point. You can just like stop me at any point. Is it okay?
Okay, sir.
Okay, fine. Now, coming to look into this case, before going to this presentation, let me talk about some general term. It's a very simple general term. Uh, what we have seen in computer terminologies is called as abstraction. Right? We have been familiar with the word abstraction. Yes. So this is from my particular point. It's a very very vital aspect of any technology that is visualized as either an IT or any technology which comes into the scape of information technology. Let me tell you this way. Like, what is abstraction? Can anyone like give me like share me what is abstraction?
Sir, excuse me, sir. Sir,
Yeah, fantastic. Showing
someone.
what? Yes, ma'am.
Yes, sir.
Yeah,
Chat box, sir.
I just like look this part.
Okay, sir.
Swaroop Rani Manur, showing what is important and hiding the complexity involved. Good, very good. Fine. Now, does it has any significance with blockchain? I mean IoT. Does it has any significance with IoT? Do you have anything which we have common, or does IoT has any kind of abstraction? If so, what abstraction is done in IoT? Okay, so from here I'll start my discussion. Rather, yeah, good, fine. Now it is related to OOP. Okay, fine, good. Now let us like talk again to the another point. Like, coming to abstraction, we go for the definition. We try to understand the definition of abstraction. Now I'll tell you, if we say we have social networking, people are very apprehensively using the social networking. Now, thinking of any application or any tool that is available today in the IT arena is nothing but it is a traditional thing that is enabled in the space of web. I'll tell you. If supposing you have a group of people, the group of people will have an organization. So then you have a group of people with special interest. You have parties, right? Political parties, state parties, and we have workers. You have workers union, and you have organizations which affiliate to castes, and these are the things of interest like that. Things were called as physical networking. So for any kind of networking we need to have a place where people will come of a common interest will come there and share their views and then have their own operations. Now this particular physical networking is taken and it is abstracted as social networking, that here we have a Facebook. In the Facebook you have a group, and that group is exactly an abstraction of the physical group, right? Am I correct? Am I right or no?
Yes, sir.
Yes or no?
Yes, sir.
Fine, fantastic. Now this is the key idea of abstraction. Now here, in this way, what exactly is abstracted in IoT? So we look into that particular perspective of understanding this IoT, right? I'll give you some few times. Let me glimpse through some of the presentations and come back to the point of abstraction. So coming to the internet revolution, it's internet of boffins and internet of geeks and then internet of masses, the mobile internet and internet of things. Now the thing is that here is a like in this particular space above 20K, that's 95 to 2000 and above, we have internet of masses and then mobile internet. Like here we had some 10 years back, 20 years back, we had browsing centers everywhere. We had browsing centers, and is the only way that you got to go to browsing internet kiosks and then you had dial up and other things. And now what has come with the case of broadband and etc. now, and then with the mobile, with the technologies like after 3G, very after 3G and 4G, data with mobility was introduced, and that was a huge success. And then slowly then came the new use case, that is your internet of things. Now here we will say like what is this internet of things or in IoT more specifically. Now like we'll see the next one. The what is the impact of internet? So it has touched the every walk of the life: education, business, communications, entertainments, medical, health. Nowadays you don't have any like what do you mean, it has turned every stone or every pebble. Now the internet usage statistics: the world population and then connected devices. Out of 6.3 billion population, 500 million are connected devices. And then it is in 2003, I mean in 2020, with 7.6 billion, 50 billion are connected. So this gives an idea that more devices are connected than people. This is one fact to understand. And now the connected devices per person is 6. For specific, if we have a we have a desktop at home, we have a laptop, we have a mobile phone, and then we have an system at our office. Minimum 4 devices you're connected, right? So this is the internet usage statistics. Then internet connected things. Now, before going to this particular slide, I'll come back, as I told you, to give about the idea about abstraction. So what is abstraction? Now we are very like with the television come into the picture, we are using remote controls, right? Yes. So what is the purpose of a remote control? Where are the devices we use remote? Television, sound systems, audio systems. Yes. Okay. It acts as an interface. Very good. Now the device or the component which you want to control is in a different place, and you are in a different place. Might possibly in the same building or same surrounding, you are able to control it, right? This abstraction at a higher scale is what you mean by IoT. Yes. How many of you agree with me in this particular point? Yeah,
Yes, sir.
fine. Yes, fine. Now, coming to the point, so like if that I am at my home that I have forgot to switch off my, I mean, like I was putting my motor, and that in mid there was a power cut. I didn't switch off the motor, and I've come back to my office. Now my home is locked. No one there that to go and switch off this motor. This is one use case scenario for you to understand. Now, think of a case that if it is possible for me, the case that if that motor is connected through internet and I have a connectivity and I am also connected to the internet, I have an interface to connect to that particular motor, that is IoT. So this is an abstraction of a remote control. What is the significance, or more specifically, the fantastic part of this particular remote is that you can be at any place, and the device or the surrounding or the environment you're going to control maybe in different continent also. So this is one way that abstraction. This is an abstraction of remote control, controlling your devices, monitoring your devices. Right? There are three. There are. What do you mean by three things? Like whenever you have a device, whenever you call a thing, so that is the reason they made it as thing, right? So it is a distributed remote, right? IoT is nothing but it is an abstraction of a remote control. Agreed? In that way, is this technology accepted? Fine. Now we'll come back. We'll come back to this presentation again. Now, when this idea of internet connected devices came, so when this idea of internet connected devices came, here by 2020, the world population is shown in the orange color. And then the internet connected devices in billions, the internet connected devices per person. So here in 2020, from 2005 till the same, it's a continuation of the Cisco source. The thing is that internet connected devices are 50, and then the population is 7.6 billions, and then internet connected devices per person is 6.58. So this is the idea. Now, the internet with the internet of people, the internet of things, right? So here is where we want to control. So here is the point: you have a signal that is connected to the internet, and you have a flower pot that is connected to the internet, and you have an appliance at your home that is connected to the internet, and you can control all these things from anywhere. So this is Internet of Things. 1999, Kevin Aston has founder in MIT the idea of IoT. He devised the concept of IoT. In 2005, the ITU Interns Report on WAS has coined the next second wave. And then in first international conference for IoT was hosted in the year 2008. So the definition, come to the definition, wireless network between objects, usually the network will be wireless and self-configuring. By embedding short-range mobile transceivers into a wide variety of additional gadgets and everyday items, enabling new forms of communication between people and things, and between things themselves. So this definition of WSI is in 2005. And number of technologies and research disciplines that enable the internet to reach out into the real world of physical objects have with IoT 2008. So the definition of IoT 2008. This is the one which I was telling you just before, right? So this is the point of the definition point. So what exactly IoT is? The IoT is the network of physical objects or things embedded with electronics, software, sensors, and network connectivity, which enables these objects to collect and exchange data. Now here, at this particular point, we need to have to give a pass and to give a good attention about ideology about the candidates which we use for IoT. Now, anything can be connected to IoT. Anything can be made as a part of an IoT. Now, the idea here is that what is the thing you wanted to do with that? What exactly you wanted to interface with that particular thing? First case is very simple. We have your CCTV cameras. What is the purpose of CCTV camera? Now, you have a home or a warehouse or an office, anything. Then you have connected your CCTV to that particular location. You have placed the CCTV camera at that particular place, and that CCTV camera is collecting the footage. And if you are publishing it through a URL, you have an application. With that application streams that particular footage of your web camera, that you can see from anywhere. This is the very first case of IoT. So what is the thing here is? The thing here is you have a camera, is a surveillance. The surveillance thing or the surveillance of that particular physical space is converted into an IoT. Agreed? Yes? Okay. So with that particular point, try to understand this particular point. With this ideology, here come the new spectrum of applications with internet, right? Now, with this thing, we should understand, we are able to understand this, what exactly IoT is, right? Now, the first thing is, simple thing is with just a mere monitoring. The second thing is acquiring the data. I can collect the data. Supposing we have a unit, and that unit is running some production of some commodities, and you have a sensor that is a counter sensor which is counting the number of units that are manufactured in real time. And with IoT, you are getting to know the number of items produced at real time. So the second thing is collecting the data. The third thing is exchanging the data. The exchanging the data is also by some way it is called as we call it as controlling part. So we will also call it as controlling part. So here, uh, like what I mean by control here is, here we are just going to for say we have a device. That particular device you are going to control, right? So control in the sense that it involves two things. First thing is getting the status or the state. This one, the arrow from the device to the user. And the second thing is we are just going to get the data, and after that, if we are going to remotely, what do you say, you are going to control it. So here is where you have the exchange of the data. Now, here is one simple thing of understanding of what exactly IoT is. So things plus sense and communication, or the communicate, like sense and communicate. So things in the IoT sense can refer to a wide variety of devices, not limited to. Now here, this particular point, you should say these are not limited to. So because anything can be made as an IoT. Now here we say it is not limited. So the device means, you say that these are the only devices to be connected? No, there are a lot. Hot monitoring implants, biochip transplanters of farm animals, electric lamps in coastal waters, automobiles with built-in sensors, DNA analysis devices for environmental food pathogen monitoring, field operation devices that assist firefighters in search and rescue operations. Coming to the dimensions, right? So as I told you, what are the dimensions of IoT? So one dimension is anything connection, means between PCs, human to human, human to thing, or thing to thing. So this is the connectivity spectrum or the dimension of IoT. And then any place connection on the move, outdoors, indoors, at the PC. So this is what I've been talking about, the remote perspective, the remote control perspective, as I told you, right? So here, the thing is at any place, and you are not also in the same place, but still you are able to connect this. And then any time connection. This means that it's about 24/7 to 365 days. So this is the dimension logic. Now here, can we look this IoT as a network of networks? More specifically, we call them as overlay networks. So here, We have the transport networks, education network, business networks, energy, others, home, and earth. So this these are the round circles represents the individual networks, and the connections between them are connected together. With security analytics and management, these networks with added security will allow IoT to become even more powerful in what it can help people achieve. So this is one thing. So the technology roadmap of IoT. So the thing is that in from 2000 till 2020, it started with demand for expedited logistics. More specifically, if you just book something, if you just like order something in Amazon or Flipkart or any online platform, you will be given in tracking. So whenever your commodity is in transit, you will be given a transit. That is for the expedited logistics. So they introduced RFID tags for facilitating routing, inventory, and loss prevention. Then coming to your supply chain helpers, cost reduction leading to the diffusion into second wave of application. They're coming to the technology reach. Surveillance, security, healthcare, transport, food safety, document management. And coming to the third technology of ability of devices located indoor to receive geological signals. So here it is possible to locate the people and everyday objects, right? So it moved from vertical market applications to ubiquitous position. Then miniaturization, power efficient electronics, and available spectrum. Now, because in India we call something called as a geo effect. When these like Swiggy and other things, a lot of applications, Flipkart, Amazon have been made popular is only because of the connectivity. So everyone is connected 24/7 4G connectivity with bandwidth, speeds, and with data. Now here, this gives a chance of physical world web. So with teleoperation and telepresence, ability to monitor and control distance objects. This is where now first, as I told you, it started with mere simple, more very simple use case of just monitoring a thing, just a monitoring of thing. Now it is possible to control, right? So then software agents and advanced sensor fusion. So it is possible for to unlimited capabilities with IoT. Now, so network. The first wave is with network consumer electronics. The second one is network industries. The third one is network everything and network society. Now anything, everything is now connected, any to any connectivity. So here, why we go for IoT is like the reasons or the wave that has created this IoT are, we have open platforms designed to make building and deploying applications easier, faster, secure, and more accessible for everyone. And it allows to create low power, wide area sensor or actuator networks (WASNs) for machine type communications, smart cities, ubiquitous sensor networks applications. It's a convergence of, like we say in earlier days, we had something called as ADAC networks or wireless sensor networks. And all these networks now converge to this IoT. It contributes to the socio-economic developments such as agriculture, health sector, and many more. And for efficient management, it manages utilities efficiently, such as smart power, water grids, and transport management. Later, we'll see the case studies. So how IoT works, the IoT can be viewed as a gigantic network consisting of networks of devices, computers connected through a series of technologies. And numerous technologies like RFID, wireless connections may act as enablers of this connectivity. Now, we look into the connectivity part or how this entire spectrum is, or the different components or the actors of the IoT arena. Tagging things. So these are real-time traceability and addressability that is provided by RFID. It's very like now we have been using all these things in your libraries to prevent. You'll be having a bay where it will sense that the book will be attached with an RFID, and if you're moving, the device will sense and tell you that the mobility. So this is tagging things. Then feeling things. Sensors act as a primary devices to collect data from the environment. This is what I've been telling about, because sensors are rather, we say, if you say internet as a revolution, internet is revolutionized by telephone networks. It's only after telephone networks it is possible for you to do your voice communication. Later they thought of connecting computers, and these computers exchange data. The third thing they just started off thinking of how to connect, like how a sensor can be connected. And shrinking things, or the miniaturization and nanotechnology, has provoked the ability of smaller things to interact and connect with things or smart devices. Right. So next we are going to, if we take the case like when we are talking about any device, we talk about any device, like maybe uh, a desktop or a PC. Earlier days, PCs were very hard in size. Now these laptops has come to slim sizes, and the laptops are shrinked. More specifically, if you take about a smartphone, it is more than a laptop. It's more than a desktop, and it is morely a 5-inch or 6-inch device. So this is another factor. Thinking things embed intelligence in devices through sensors has formed the network connection or to internet. It can make things realizing the intelligent control, right? So coming to the architecture, so far we have seen briefly and informally about what is IoT. Now, what is IoT? Its definition, the possibilities. Now, clearly, the first layer starts with the device layers or the sensor layers. The second layer is the network layer, whether I'm connecting with Wi-Fi, 3G, LoRa, WPAN. So these are the things that are used for the medium and connectivity. And the third one is the service layer, like which provides computing, information processing, data collection and processing. As usual, the last one happens to be your application. So how the user gets access to these devices and control, etc. And then it's health for agriculture or cities. And altogether, it has the management perspective to be addressed, the management issues to be addressed, and the security to be addressed, because these devices carry and sense sensitive personal real-time data. Now, it should not be breached. So security is a part. So this is the very primitive or the basic architecture of IoT, right? So with this brief, with this very small uh, uh, brief of IoT and architecture, like I just wanted to get you back. Like, do you have any other questions? Do you have any questions? So far, is okay. Okay. So I hope so far it is good. So now we go to the IoT infographics. I'll show you an IoT infographic. Now here, so this is Internet of Things. We look into this infographics. Now here, so this says Internet of Things, to become connected an object, like in to become connected an object must be able to capture data and transmit data. So you should be able to capture data and transmit data. So this is the part. Then 2003 till 2010, right? But 10 to 20 billion things connected to the internet today. This is in the year 2010. By 2020, this number is estimated to grow to 40 to 50 billion. So this is as per 2010. That's roughly 5 connected devices per person on the earth. Anything that is hard to monitor becomes easy, and it's because of rise of the sensors, right? Now here is that sensors data are connected, and Now, every device nowadays, like this is another thing you need to know. Every device have between 6 to 9 sensors. Your mobile phone, it has a light sensor, accelerometer, magnetometer, motion coprocessor, ambient sound detector, and gyroscope, parameter, temperature and humidity, and proximity. So these sensors are available in your devices, bare minimum, more specifically, or more in a simple term. So then cheap sensors are accelerating the growth of IoT. So the decrease in the cost of sensors has fueled the number of connected devices. And then with the mobile, it's in the mobile. So a new economic age, the 2020 annual global economic potential across all sectors is estimated up to 14.4 trillion. That is the current GDP of the European Union, right? So these are the revolutions, right? And which are all the industries that are benefit from IoT are automotive industries, banking industries, marine industries, properties, energy, aerospace, healthcare, manufacturing, and food. It has covered all verticals and all horizontals. Now the risks, right? What are the opportunities generated by IoT far outweigh its risks? For business to fully realize the great potential of IoT, they will need to be prepared for these risks that lie ahead. The insurance industry is well positioned to help business navigation in an IoT world. The privacy, cybersecurity, and liability are the major risks to be addressed by IoT. And the other the things are safety, driverless cars, and worker accident prevention, decision making, data driven insights, efficiencies are biometric banking like smart TV and thermostats, the infrastructure risk triggers, electrical networks, and predictive maintenance. So this is one handy like infographics by AIG, right? So it's the IoT infographics, right? So we'll show in another IoT infographics to get to know about the potentials and penetrations of IoT. The aggregated rate CAGR, 30% of aggregated rate, and 1.7 trillion industry by 2020. Industry is most likely to first adopt IoT for manufacturing, healthcare, transportation, energy, retail, agriculture, and electronics. 96% of sensor business leaders plan to use IoT in next 3 years. 94% face challenges collecting and analyzing IoT data. This is a very, what do you say, a potential opportunity. Only 7% have comprehensive strategy for IoT. Still more to grow. So 31 billion devices and 4 billion people will be connected to the internet by 2020. IoT will benefit every industry, real-time data aids and analysis, improved customer experience, new jobs in flexible organizations, reduced time to market, intelligent machines that will automate the tasks, elimination of waste in supply chain. So these scenarios, these case studies, right? So with this particular uh, data infographic, right? Sorry. So this is the architecture, right? So this architecture is the base architecture or the primitive architecture of IoT. Now, still with the things, the another thing I wanted to tell about here is the device management. I'll come to this particular slide. So this is from Mule Software Incorporation. As I told you, the lower level is the device layer. The device layer, I'll tell you the rise of the microcontrollers. The microcontrollers again play a very, very vital role in enabling and making IoT a game changer. So here the sensors and the boards, we call them as the microcontroller boards, and then your device hub or gateway and the device management, and then the data management, and then your APIs or the interfaces by which you can design and build your IoT, and for your runtime management, and the websites and industry specific applications, mobile apps, and platform as a service middleware. So here in the lower level, you can see the ARM, Raspberry Pi, Intel Galileo, and these are all the boards. And NVIDIA GPUs for your GPU computing, and AMD all as well, and then Arduino for your boards or the microcontroller boards. and Qualcomm for microchips, and all kinds of sensors, and all kinds of sensors. So here, if when one analogy, if we take network, ordinary computer networks, the networks are provided by devices, switches, bridges, and routers, and connectivity protocols. In the same way with IoT, the basic layer, it's going to be the device layer. It's nothing but the sensors, the microcontroller boards, the gateways, the LoRa devices, Zigbee, and the communication part, and comes your application, and comes your middleware, and comes your security and your applications. So this is the architecture. So then coming to your applications. So what are the applications of IoT? So domain specific IoTs, vehicle, asset, person, and pet monitoring and controlling, agriculture automation, looking to monitor energy consumption, security and surveillance, building management. Everyday things get connected for smarter tomorrow. Telemedicine and healthcare. This is the need of the hour for a pandemic, to fight the pandemic. Smart houses and cities. Everyday things. MTM wireless sensor networks. Embedded mobile. So these are all your domain specific IoTs. So the IoT applications are there for home, cities, environment, energy system, retail, logistics, industry, agriculture, health and lifestyle. All it has covered the entire thing. I mean, entire vertical and horizontal of your industry. We look into this one by one. Home automation, IoT application for smart homes, smart lighting, smart appliances, intrusion detection, smoke or gas sensors, right? So here, all these things, the water heater control, sorry, the water heater control, which has an iron, and then you will be able to on and off the table mount touchscreen, and a wall mount device, and a wireless device, and internet control and dimmers. So if the person is not there in the house, nobody is there, it automatically dims the light, switch off the light. And if nobody is there, and if the TV is running, the TV can be run. And then if case, any case you have a chance of fatality, like some kind of leaks or smoke and the gas, it's been detected and automatically reported. So these things with home automation. And we have your so Google Home, and Amazon Alexa, and a lot of things to come around with home automation. And smart lighting, so it's very simple use case, energy saving by sensing the human movements and their environment and controlling the lights accordingly. So the solid state lightings such as like LEDs and IP enabled lights, the wireless enabled and internet connected lights can be controlled remotely from IoT applications such as mobile or web application. So this is one research article on this particular theme of smart lighting for home automation. And for smart appliances, it's just like it is easier to provide status information of appliance, that is washer or dryer. You have been using your washing machine, dryers, etc. Open Remote is an open source automation platform for smart home and building that can control various appliances using mobile and web applications. The three components: you have a controller, you have a designer, and you have a control panel. So it is, and it's called as ICICP, IoT based appliance control system for smart home, as with this particular decision on the year 2013. So it's implemented an appliance control system for smart homes that uses a smart central controller to set up wireless sensor and actuate a network and control modules of appliances. Intrusion detection. So home intrusion detection use security cameras and sensors to detect intrusion and raise alerts in the form of SMS, email, or snapshot, or the picture, or the screenshot, or the image grab, or the short video clip. So it could control intrusion detection and burglary prevention stratagems in home automation systems, as with this particular paper of 2012. It presents a controlled intrusion detection system that uses location-aware services, where the geolocation of each node of the home automation system is independently detected and stored. An intelligent intrusion detection system based on PNP technology for smart living. It implements an intrusion detection system. It uses plug and play instant messages for alerts. This is the the third category of intrusion detection. The last one is the smoke or the gas detectors. Smoke detectors are installed in homes and buildings to detect smoke. That is typically an early sign of a fire. It uses optical detection, ionization, or air sampling techniques to detect smokes. The form of the alert can be in the form signals that send to a fire alarm system. Gas detector can detect the presence of harmful gases such as carbon monoxide, liquid petroleum gas, etc. So this article, the development of multipurpose gas leakage and fire detector with alarm system, can detect gas leakages and smoke and give visual level indication. So moving to the second spectrum of cities. Now I'm break here and like to get your interim feedback. Is it okay? You're able to follow? Is it interesting or it is boring? Dear participants, uh, is it okay? The session is okay? Do you feel something useful? Yes. I think I don't get any reply. Okay. Thank you, Nagama Lakshmi. Thank you. Thank you. Right. So now, coming to this case, we look into cities, IoT applications for smart cities. Parking is a major problem whenever you go any places with expanding cities. Smart parking and smart lighting for road and smart road, structural health monitoring, surveillance, and emergency response. So these are all the case studies for smart cities, right? Now this will look briefly. So finding this parking space in the crowded city is time consuming, and it is if it is easier if I'm moving from one place to another place, if by the time I'm reaching the destination I get a parking slot, right? It can detect the number of empty parking slots and send information over the internet to the smart parking application, which can be accessed by the drivers using the smartphone through the navigation system via their route to the destinations. Sensors are used to each parking slot to detect whether the slot is empty or not, and this information aggregated by local controller and sent over the internet to database. So the system architecture is called as Spark, Smart Parking. So it's maybe it is a pretty old paper. You may have recent references also. Smart lighting of roads. Right now here, if at all you want, in one of the cases we have seen many cases where the street lights are seen illuminated even in daytimes. Maybe. So it can help in saving energy. Smart lighting for roads allow lighting to be dynamically controlled and also adaptive to ambient conditions. Smart light connected to the internet can be controlled remotely, and we can set schedules and lighting intensity. Custom lighting configurations can be set for different situations, such as foggy day, festival, etc. So this is another paper with smart lighting solution for smart cities. Describe the need for smart lighting system in smart cities and how to develop interoperable smart lighting solutions. Smart roads provide information on driving conditions, travel time estimates, and alerts in case of poor driving conditions, traffic congestion, and accidents. This is almost now available with a base version is available with your Google Maps. Nowadays, we navigate through Google Maps, and Google Maps gives you a very fantastic all-round information about all these things. Structural and health monitoring. So it uses a network of sensors to monitor the vibration levels in structures such as bridges and buildings. The data collected from these sensors is analyzed to access the health of the structures. By analyzing the data, it is possible to detect cracks and mechanical breakdowns, locate the damages to a structure, and also calculate the remaining life or the possibility of a fatality or breakdown of the structure. Using such systems, advance warning can be given in case of imminent failure of the structure. So these two articles discuss about the structural health monitoring. Surveillance. Surveillance of infrastructure, public transport, and events in cities is required for the safety. And citywide surveillance is by through video surveillance cameras. The video feeds can be aggregated in cloud-based scalable storage. Cloud-based video analytic applications can be developed to search pattern of specific events from the video feeds. Then your emergency response. The IoT systems can be used for monitoring the critical infrastructure cities such as buildings, gas and water pipelines, public transport and power substations. IoT systems for critical infrastructure monitoring enable the aggregation and sharing of information collected from a large number of sensors. Using cloud-based architecture, multimodal information such as sensor data, audio, video feeds can be analyzed near real-time to detect adverse events. So alerts sent to public, rerouting of traffic, evacuations of the affected areas in case of any fatality, flood, volcanic eruptions, earthquake. So that kinds can be very efficiently be managed and handled. Coming to this environment. So far we have seen the home and the city. Now we come to the environment, still a higher level. So, like any queries so far? Do you have any specific queries, or you want to uh, tell me with another perspectives? Any other perspectives? Okay, Swaroop Rani. Okay, thank you. Now, right now with this, we'll go to a small infographic, and we have seen an infographic. We look into. Let me open a browser. So, with this case, I'll do a search of IoT sensor lists, and I go to images. Top sensor types. We look into the sensor types. Here, it gives gladly the most active Internet of Things investors to give to know an idea. This is one thing. Now here, this infographic will give you a smart world. What is the environment? So this particular thing is the most active internet investors in the last 5 years, right? Uh, Now, let me. So this is your CP Insight. Let's call it the CP Insight. So let me show. The first is the Intel Capital with the ventures, and then the these are all what do you mean by the venture capital for these companies like these Aeroscout, Mark One, Airwave, AP, OTAM, Planeton Technology, Performance Labs, Razer. For these companies who have been working in what do you say the IoT platform, Intel Capital has provided funding. Coming to Qualcomm Ventures, hello. Going to Qualcomm Ventures, you have a 3D Robotics, Astrip Technologies, Alive Corp, Avac, Concert, Fitbit, Anita Systems, Lifix, etc., etc. So these Visual Labs, we'll see to say what each is. We'll just go to one particular thing. We will see what is this Visual Lab. Now, this is one case which gives you. So here, this thing is a visual 360-degree pet tracking. This particular case study we might have not thought in our country. Yes or no? So here is that we have the neck strap, and this particular device is connected to this particular pet's neck trap, right? Now, for this particular company, Qualcomm has did a venture capital funding, right? So they have possibility that if this particular technology, so we'll see Fitbit, right? So we'll see this Fitbit. I don't know whether we have these things, or we'll say Skycatch. Now we'll just go and see Skycatch. Professors, are you following me?
Yes,
Is it
sir.
is it okay, ma'am? Is it interesting?
Yes, sir.
Because I don't get any interaction. For that reason, I'm just time and again switching back and seeing any chat or other things. But none of you interact. For that particular reason only, I'm just clueless.
Also, we are all listening, sir.
Yeah, thank you. Now, so we look at this particular Skycatch or Sotira, or we'll see what happens. We'll see Skycatch. IoT. Skycatch and IoT. So here, Skycatch works on the drone data collection. Now, this emblem says this is that. Like from this infographic, this Skycatch is a company. Now here it is drone data solutions, enterprise grade drone mapping and data analytics. Now coming to the solutions, high precision package for mining, and then the technology that they're working with is IoT maybe. Creating highly precise 3D site data consistently is hard. Attaining it rapidly is even harder. Skycast technology is like they are is reliable, accurate, and fast. Right now, these are all the advantages. Like you have 13 issued patents covering its core technology. The first company to ship an end-to-end real-time based drone survey system. We have been providing our customers with RTK capable drones and processing since 2016. Through this technology, we have enabled customers to get the highest accuracy data without the setup time and safety risk of a GCP-based drone system. Right? So, like, like you can just go through and find out what happens in this Pretoria and what happens in this particular plane. Once and win, like every all these are more specifically into one way and another way into these things. Now we look into the another funding that is from your Foundry Group. Next one is your Cleaner Perkins Caulfield and Byers KPCB, and Anderson Harowitz, Koshla Ventures, True Ventures, Cisco Investments, and then New Enterprise Associates, CQO Capital, Firstone Capital, and SV Angel, and Crunch Find, and Felicis Ventures. Now here, if we just look into these things, Airwave and 3D robotics are seen be funded with more things. Now here you can see the little bits that has been almost here, right? Excuse me. So this is one predicting of the most active IoT investments 2010 to 15. So this is 5 years old. So this is 5 year old. Anyway, let me share this particular link for you to get to know to be a reference. I just put this in your chat window. At a later time, if you wanted to have a browse look, you can just look on it. So this is the link of that particular scale of VC investments, right? So this is another infographics of fundings, right? Then now, since I am talking about smart environment, this particular uh, infographics shows the 50 sensor applications for a smarter world. Now, it's it's purely with an environment. It's purely with an environment. Now here I can detect air pollution. I can look for forest fire detection, and then look for your wine quality enhancing, and then offspring care, sportsman care, structural health. We have covered smartphones detection, perimeter access control, radiation levels, electromagnetic levels, traffic congestion, smart lighting, intelligent shopping, noise urban maps. They're pretty, what do you call, water leakages, vehicle auto diagnosis, item location, waste management, smart parking. Now, waste management, now, if supposing like many of you are professors, if you are many of your colleges may be asking you to submit some research proposals, the very thrust area wherein you can just very uh, one second. Right. So these are all the scenarios. Like first thing is your clean air and clean water. Sustainability is the next thrust area. Next one is your waste management, sustainable waste management. It's very hot thing, clean and green energy. So look on these particular case studies and then like make some proposals on that. You will surely be getting your proposals. Work on it. Work on them because like this is very potential field where you have a lot of penetration to be done for waste management, right? Because the plastic waste, e-waste, that's very what do you say, deadly, and you have less penetrations, right? So this is the thing. So the list is grouped in 12 different verticals, right? Like the law, so the smart city, smart environment, smart water, smart metering, security and emergency, smart. So this is one thing, like which controls, like this is the things. And then this particular company has IoT services, the IoT products. So the vast mode, plug and sense, Michelin parking, Michelin scanner, and my signals. And then solutions for agriculture, water, environment, cities, parking, industry, tracking, retail, tourism, and e-health. This is another infographic. So having seen them, so brief into the environments, IoT applications for smart environments, weather monitoring, air pollution monitoring, noise pollution monitoring, forest fire detection, and river flood detection. So as with the different levels of ultraviolet rays, penetration, carbon monoxide, nitrogen dioxide, and smoke level can be thin. So a framework called as your PEWEMOS, Pervasive Weather Monitoring System. It presents a pervasive weather monitoring system that is integrated with buses to measure weather variables like humidity, temperature, and air quality during the bus path. Then air pollution monitoring, it's the pollution monitoring can monitor emissions of harmful gases by factories and automobile industries and like your vehicle emissions, right? Then noise pollution monitoring, so it can help generating noise maps for the cities. It can help the policymakers in making policies to control noise levels near residential areas, schools, and parks. It uses a number of noise monitoring stations that are deployed at different places in a city. The data on noise levels of the stations is collected in the cloud, and that collected data is aggregated to generate noise maps. Right, right, right. Now, having given these scenarios, uh, we look into the another perspective. We look into another, as I told you, the sensor. Uh, in the sensor's perspective, uh, as I told you, the critical part is your microcontroller. Now we come to this particular point and look into why we have these microcontrollers, right? We say Raspberry RAS, Raspberry, Arduino, Node ECU, Node MCU. Right. We look into these things. Now, what are these particular boards? Like why we are concerned about this particular boards are for any IoT based application, you will have sensors, and these sensors cannot be interfaced with your computers. So that is the real problem, right? What are the things you can interface with your desktop or your PC? What are the systems you can interface? I can connect my audio device. I can connect my video device. Standard ports. I have an USB port. I have a VGA port, and I have a HDMI port. Right. Any device and any interface which can be connected is only through that particular devices. Now coming to your what do you say, the IoT space. Now I wanted to connect what do you say, the sensors, right? To connect these particular sensors, we need to have something called as your GPIO. So we'll understand this GPIO. So this GPIO is a braking technology, that is the powering technology more specifically, which shows more specifically as with as I've been talking about all these these sensors cannot be interfaced directly to your machines. Sensor is there, sensor is collecting a data. Now, how that particular data can be fetched to your application, right? So for that, we need to have special devices. That is where you have your Raspberry, Arduino, and Node MCU, right? It's Node MCU is one thing. You have a lot of other microcontroller units, very handy user units. So here, what is this GPIO is? Your GPIO is your general purpose input output. It is a standard interface used to connect microcontrollers to other electronic devices. Or more specifically, it is not other electronic devices, it is simply your sensors. For example, it can be used with sensors, diodes, display, and SoC, system on chip modules. So have this in mind, like why we need this particular things. Supposing if you're just going to talk about an agricultural management system, and you're just going to say control an agriculture farmland of say some few 50 acres. Now we'll take 10 acres more specifically. Now you had some 50 or 100 sensors, and for every 10 sensors you wanted to have that particular sensor data to be collected and aggregated. So you wanted to have one such board or one such microcontroller, which is more specifically, which connects your what do you say, your sensors data and sends you through, or more specifically collects the data and hooks to the cloud. So the three parts more specifically is, so this idea gives you a very fantastic layout of your all your GPU pins of Raspberry Pi, and like this is another point we wanted to touch upon for this building blocks, right? And next thing we'll talk about like if you want, I'll just share this particular link as well for GPIO for you to get to know. Copy link address. Samrat Sham. Samrat is present. No. Fine. So this is one thing about your GPIO. So I want to talk about general purpose input output, because you don't know how to directly connect the sensors, how the sensor data reaches your applications. The next part I wanted to talk about is Like first we have a sensor, and then your MCU, and then your cloud. So sensor, MCU, and cloud. So here, the thing is that coming to this particular, you have another things like here is architecture. We've been talking about this gateway. We'll be talking about these gateways later. Now in this particular case, here rather we'll come to this particular point. Now here these are the sensors or the actuators to collect the data and to connect an interface. You're connected all these things to the microcontroller. So this microcontroller may be Raspberry, Node MCU, or Arduino ARM Cortex or Arduino or anything. And this microcontroller should have a communication facility. It may be through Wi-Fi, it may be through LoRa, it may be through Zigbee. And this particular data can be sent to a specific machine or a server, or it can be sent to the cloud. Right? So here is the point you need to understand. So the next major thing we'll talk about is we'll talk about IoT communication, IoT communication models or protocols. So we look into this, and here is the case, the communication models. Here we see this. We'll see this one. So here, cloud, device to cloud. We'll open this. This is an image. Let me strike. Right. So this is a device. It's device to device, and through the cloud. And the thing is, device to cloud and device to gateway. Now we'll talk about gateways, right? So IoT communication model. So these are the models, right? Devices can communicate among themselves, device to persons, and device to device, right? This is one particular model, and here we look to this IoT communication model as well. Sorry, it is opening a video.
Hello friends, welcome to Engineering Tutorial. So monitoring.
We'll go to the IoT communication models.
So in
So
this
these
video
are
we are going
the
to
things
discuss
that
about
we can see: the request response model, push pull model, publish subscribe model, and exclusive pair. So these are all the things we can see. This consists of a client and a server for the first model, request response model. Uh, Likewise with the other types, right? So these are the communication models of IoT. Then we look into the uh, different types. Remember these particular things. We go to IoT communication protocols. So this gives you a plenty of technologies, communication technologies that are used for capturing once this data from the sensors are captured, how this particular data is being sent to the cloud or to a device or the server. So Bluetooth and cellular networks, Wi-Fi are common. Zigbee, Z-Wave, NFC, and LoRaWAN, they are the candidate applications. LoRa, I'll tell you, I'll just tell you, this is another thing. So this link will just give you. So the IoT communication protocol. So this is a data flyer tutorial for a blog for your IoT. That also will share it in the screen. of your chat. So, the IoT protocols. This is the IoT protocols. So you have another thing that's called as your MQTT. So your message queue telemetry transfer protocol. Like I don't go touch on these things. I'll come to the previous one. 7 important communication protocols. This is for the communication. Right? I'll come to LoRaWAN. So Bluetooth role in the future of IoT. So Bluetooth and network hub. Zigbee is similar to Bluetooth and is majorly used in industrial settings. It has significant advantages. Uh, here you have a Zigbee device, and then Z-Wave is a radio frequency communication, and Wi-Fi we know we're very familiar with using it. Cellular networks we know 3G, 4G, and other things for IoT. Then NFC is a near field communication. Most of the devices are like comes handy with things. Now here, LoRaWAN is one popular IoT technology, wide area network. So this is one thing you need to understand. It's the range is up to a few kilometers, right? So the range of LoRa devices are the LoRa connectivity is up to few kilometers. So this part, the another communication protocol part. So that to be clear. So for that we need to have a gateway. So for that I'll say you wanted to have a IoT gateway, right? Right. So this is what you mean by an IoT gateway. So this gateway is an interface between the things and the cloud. And this gateway will connect to the cloud through any of LoRa or Wi-Fi or Zigbee. And these devices are connected to the gateway through microcontroller and GPIOs. Is it clear? So it's a slightly a higher plane of understanding the abstraction of okay, how feasible is it to push all the computing decision making work to cloud? Yeah, it works very pretty. It'll work well because most of the clouds are now extensible and it gives you more processing power. I'll show you later with Amazon solutions for IoT. So far, the session okay is interesting. Somebody is following and uh, any specific queries or things? Yes, ma'am. Kyle Willie, ma'am.
Sir, it's really interesting, sir. We are all following you, sir.
Yes, ma'am. Like, if you have any specific queries, like where I wanted to address on any specific queries?
No, sir, it's going nice, sir.
Okay, ma'am.
The session
Okay.
is very
Okay.
informative.
Swaroop Rani, madam, it's like I'll next time just show you that how this cloud. Your question is that will the cloud be scalable and it will be robust? Yes, am I correct, ma'am? Fine. Let me come back. Let me come back to those things. Any other questions for any other participants? Any of the professors? You have any other questions? Okay, I'll go to this session. Now, now the third part I wanted to. I've talked about the first thing we have talked about sensors. Second thing we have talked about the microcontrollers. The third thing, microcontroller is like parallel with gateway. And third thing I've talked about the communication part, like how your gateway is connected to the cloud, right? Now we come to look into the IoT support. Rather, I wanted to tell you the very very popularly used cloud for your IoT data is your ThinkSpeak, right? So here, very simple. We'll see a video if possible. Home things, ThinkSpeak, how to analyze IoT data in ThinkSpeak. If you don't mind, I'll play this video. Yes.
Have you ever wondered if the error
Yes, sir.
is like to run
We're able to hear the voice, video voice.
Yes, sir, it's coming, sir. Audible, sir.
Now, this particular tutorial, they are interfacing the sensor data to ThinkSpeak Cloud with MathWorks, MATLAB solution.
Yes, sir.
Might be I'll just go to another video. Like this is more specific to the API part. I was looking for a video which shows how a sensor data can be plugged into your ThinkSpeak. It's very simple. Once you have an account, ThinkSpeak will give you an API key, and you can configure that API key with the IoT channel. The data will be automatically connected. So that is one thing. Briefly, I wanted to tell on this particular ThinkSpeak. Now with Swaroop Rani ma'am, let me give you AWS IoT services. We'll look into the AWS IoT services. Like here, Amazon has plenty of services, right? Now here is this links gives you like I'll just give you the link of ThinkSpeak also. Right, I'll copy this link and share you in the chat window. Click. And then I come to Amazon. Then I come to Amazon. Right now, now like AWS and AWS IoT. So any it's not only with what do you say like IoT. Amazon has developed. You name any technology, Amazon has its solutions to that particular technology. So you don't have to worry, right? Uh, Let us see. Here we'll glimpse onto what are the AWS IoT things that are available, right? So here it gives you the thing. It enables secure bidirectional communication between internet connected things such as sensor, actuator, embedded devices, smart applications, and AWS cloud over MQTT. Now, as I told you, this is the protocol that is used to receive data from the gateway to the cloud. So this protocol later you will be learning about these particular protocols, right? Right now it gives you a great idea about how to do with these things. Getting started with AWS. Sorry, I went somewhere, leaving Amazon, AWS at Amazon.com. One second. Right. So it is this particular provides the services. It gives you the use cases: industrial, connected home, commercial, and device software, and the connectivity, AWS to IoT core, AWS IoT defense eventer, AWS for IoT analytics, site-wise events, IoT things graph, and these are all the case studies. You can just go through and see how this is used. We can see the IoT solutions. We have the IoT solution repository, and then the partners. I'll give you the IoT solution repository for you to understand. Right. Sector wise, you have industry wise, you have solutions, right? AWS connected device solution. Uh, so how to implement is also there. Now they give you the caps. Like you have Lambda. AWS Lambda is one service. It's very like it's been the service messaging service that will be used, right? So this is the connected vehicle solution architecture. You have like this. Amazon has a lot of like what do you say? You name any vertical AWS gives that particular solution to you, right? So this link to I'll share you in the chat window. So Rupani ma'am, is this okay?
Yes, sir. I will just go through the links, sir.
Yeah.
Thank you, sir.
Yeah, it's there. A lot of things are there. Like it's not only with AWS, even like Microsoft Azure, rather like what do you say? IBM. IBM also has an like I'll show you IBM Cloud IoT support. They have a lot of support for yeah. So the IBM Watson IoT platform. So also gives IBM Watson also gives the services. This is an ad. Sorry, I'm sorry. So this is the IBM Watson IoT platform. Rather, like I'll just share this particular link also for you for reference. Right. Okay. Um, Kyle Willie, ma'am. Kyle Willie, ma'am.
Yes, sir. Yes, sir.
They add them this, that folder also for
Oh, okay, sir. Okay, sir. Sure, sir.
For the other viewers, like IBM Watson was recently conducting one build-a-thon specifically for IoT. That company, I mean, the authorized persons who were running that particular workshop was called as a smart interns. Smart interns. They had they are the what do you say the partners of IBM Cloud, IBM Watson, and they have rolled out that particular thing. So I'll give that link also for your IBM Cloud. This is the Internet of Minds, like collect from data and build, power from dashboards, device management, connectivity, communication, etc., etc. So all these things are available. The only thing you wanted to put in your time and look into that and say like how it works for. I'll show you the smart interns site also. The smart interns is project-based learning and remote internship. So it is not sales promotion. Don't take me the other way. Like I attended an like what do you say an FDP or a build-a-thon with Amazon for the Amazon's thing. I mean IBM. Sorry, I'm sorry. IBM Watson IoT platform. So they have given an intern. It's not an intern; it's an FDP. There, I just attended that FDP, but didn't complete the case study because I'm a senior professor. Senior professors almost do a lot of document work. Very rarely communicate and share experiences with the peer students. So here, this is one particular place with this particular participant is the alumni partner of IBM, AWS, and all these things. Challenges over there, like this is your IBM Buildathon. I've been talking about this Buildathon. They will give you a sample IoT case study, real time. What do you say? The problem statement, and it will be guided. You will be given with a mentor, right? So you can try this also. So I will share this also. Don't think this is not a sale promotion. I just like wanted to share you like which from where I've learned the IBM Watson IoT support. A lot of things. IBM Watson dashboard has a lot of IoT support, right? This is in brief some things about these things. Kyle Billy, ma'am,
Sir, yes, sir.
like how long should I engage, ma'am? How long should I take?
Uh, Sir, how much time you want, sir?
Ma'am, I'm almost done with my part and the case studies, and I've covered my case studies also.
Okay,
Another
sir.
5 minutes, ma'am. Another 5 minutes.
Okay, sir. In another 5 or 10 minutes, sir.
Okay, ma'am. So just
Okay, sir.
I'll just like glimpse this particular presentation. Which
Okay,
are
sir.
the things I wanted to share? I've shared with this forest fire detection, liver fire detections for energy, smart grid and renewable energy systems, uh, retail inventory management, smart payments, and smart vending machines. Uh, Kindly, ma'am, can you please mute your mic? Uh, IoT applications and smart retail systems for inventory management, smart payments, smart vending machines, and logistics or the fleet tracking or shipment monitoring or remote vehicle diagnostics. Now here, I wanted to show you another one venture which does pretty good with this inventory. So that company might some of you might have known. That company is called as a Four Kites. Right, Four Kites is a company. Um, Four Kites. Four Kites. Yeah. So here, this is one pretty pioneer leader company which does real-time visibility for your supply chain. So it has a platform, it has a network, and it has resources, right? So this company does very fantastic with your supply chain or the tracking of supply chain. That is how we track over 1 million global shipments every day and why that matters. So this is one pretty, what do you say, good thing to look into the fleet management more specifically, as of it I know. This also, so this is another thing to work with. So with this brief discussion, later in my presentations, I've given a few applications, real life examples. You can very well go through. It's all self-explanatory and thing. So the first one is Happy Fork, then smart toothbrush, smart egg tray, glucose monitoring, smart washing machine, smart piggy bank, hydrophonic system, smart home security, and smart pet management. I've shown you another thing, right? Smart lighting, smart AC, smart sleep systems, blood pressure monitor, and then smart weather station and slow cooker, tennis racket and smart bike, and smart garbage cans, net, smart mirror, smart gardening, and smart cardio, smart car lock, and socks. Save your IoT and big data. So the last thing is that When it comes to the sensor data, you have a lot of data coming into, and now it is big data is a hype word now been revolving. Earlier it started with data mining and warehousing. It has went to big data, and now we have your data visualization. So here, this is the next architecture is that you have a cloud, and from this cloud you are just going to interpret the data. You have a lot of libraries for this big data, right? So the future of the IoT is by 2025 it is estimated that there will be more than 21 billion IoT devices. More cities will be smart. AI will continue to become a bigger thing. 5G networks will continue to fuel IoT growth. Cars will get smarter, and the industrial IoT and consumer IoT sectors. And then the summary is these are the application areas not limited to. As I told you, these are not limited to smart cities, smart environment, smart energy, smart agriculture, e-health, retail, logistics, and industrial control. Um, this one philosophical view is nothing ever exists entirely alone. Everything is in relation to everything else. Thank you all. Any questions or any queries, I'll be happy to address. Any queries, any questions, ma'am?
Audience, if you have any queries, kindly ask.
Okay, maybe the afternoon session, post lunch session. Yeah, I'll share my ID also, please. Just share my email ID. No issues. Any other things at any time offline you wanted to reach to me, you can just like I welcome. Um, 1 second. Uh, and this is my mobile number. I'm available in WhatsApp and Telegram. Security is not a problem, Mahalakshmi ma'am. Not a problem in the sense that, when cloud started, people are talking about security and other things and other stuffs, and now no longer people are. You have a lot of protocols and procedures which take very better security features. Okay, thanks, Aditi Reddy, for your feedback. Okay, so you have noted down your my lady and my mobile number. I'm there in my WhatsApp and Telegram. Please feel free to reach me out at any time. And thank the management, the department, and the HOD ma'am and the Calvilli ma'am for making me witness this particular thing. So whatever I have blabbered this 1.5 hours about this particular point, I'll dedicate it to my best teachers, and then wish you all great success. Thank you.
Thank you, sir. Your most valuable speech impressed everyone, and it was an eye-opening on IoT among the participants. It was really an interactive session along with essential attitudinal behavior required for the budding research scholars and faculty members. We are sure all the participants would have reaped the benefits out of your talk. Once again, we record our hearty thanks for the pains taken to be with us and for your praiseworthy contributions towards
Sorry,
the
ma'am.
successful
Anyway, it's the
conduct of
last
the
minute
session.
thing. My session
Yes,
was
sir.
supposed to be my day after tomorrow.
Yes, sir.
Thank you, ma'am.
So you explained every aspect of IoT with real examples, which are really useful for us. We acquired a lot of knowledge on IoT, sir, from you. So
Thank
we
you.
are eagerly looking forward for more such interactions in the years to come.
Thank you.
Audience, participants, thank you for being a wonderful participants here today. Hope this continues in the forthcoming sessions also. Let's
Thank you.
meet in tomorrow's session by 10 a.m. Thank you all. Thank you,
Ma'am,
sir.
Jabin, ma'am.
Sir, good evening.
I want to
Surendra
take
sir.
your feedback, ma'am.
Yeah, it's a very nice session and actually very interactive also. And you have shown so many YouTube videos and then current, we can say that what really technology, so what the society is in need. So that
Yes,
thing you have covered a lot. and I have seen all your presentation, and as well as your YouTube videos and everything, examples, case
Thank you,
studies,
ma'am.
everything, sir. So very
Thank you.
wonderful session, sir. Thank you very much, sir, Surendra, sir.
Thank you, ma'am.
Thank you very
Thanks
much.
for the
Thank you, sir.
opportunity, ma'am.
Thank you, sir. Thank you. Thank you. Welcome, sir. Welcome, sir.
Ravi, sir, Ravi Kumar, sir, do you have any feedbacks or anything? Okay, ma'am.
No, sir, it seems so.
Okay,
Sir,
ma'am.
shall we wind up, sir?
Yes, ma'am. Thank you, ma'am. Thank you, ma'am.
Thank you,
Sir,
sir.
sir, Surendran, sir.
Yes, ma'am.
Sir, one ma'am is asking any reference to study more, any textbooks you are suggesting?
Textbooks for IoT. I'll just share it, ma'am. I'll just mail you through. I'll just send my presentation and mail you a comprehensive list. If any, I have a book, I think I have to search for it and send you, ma'am.
Sir, you send it to me, sir. I'll
Sure.
forward that in the group,
Sure.
sir.
Definitely, ma'am. Thank you.
Okay, sir. Thank you, sir.
Thanks a lot.
Thank you, sir. Thank you, sir.
Thank you all.
Bye.
Thank you.
Thank you.
Bye.